by reactance xn. So 3xn will be added to the generator. 3xn will be only in case of the transformer we can add it. So that has to be seen when we are going for the zero sequence. Zero sequence, it's very important. But positive sequence and negative sequence, it doesn't have any impact, this grounding that I have told you already. So positive sequence for this will be, have a look. So this is, first you have a generator, reactance of generator, and voltage source we have. Just a second, I will look into the diagram only. Generator, voltage source. In parallel, another generator we have. Okay. And we have reactance of that generator, and we have a voltage source of that generator also. Okay. Then after that, moving to this side, we have a transmission line represented by reactance. Sorry, transformer 1 represented by reactance in positive sequence. Transformer 2 represented again by the reactance. And then we have only again we have a generator. Okay, so that generator will be represented by a voltage source, a reactance, and the voltage source. I hope positive sequence, I have told you how to draw these diagrams. So today we'll be doing some numericals so that you can refresh yourself. So voltage source I'll be drawing now. So I have voltage source here, I have voltage source here, I have voltage source here. That's all. So generator 1, reactance, I will write it. In general, he has not given any value. So in general, we are writing xg1. So this is your eg1. You can write any notation, no problem. And then xg2, and this is eg2. This is again a voltage source. Generator 3, again we'll write the reactance here, xg3, and this is again eg3, just representing the voltages of reactances and voltages of the generators. So transformer T1 will have only a reactance. Oh, sorry, there is transmission line I have missed. Let me include transmission line here. Okay, so then we have a transmission line. You can see between two transformers. This will be transmission line represented by reactance. And then again the transformer 2-1. So this will be represented by XT1, and this is XL1, XT2. So positive sequence is very simple. In generators, we have to include voltage sources that I have already told you. Let's come to the next is negative sequence. Okay, negative sequence, have a look. I will copy this so that we can, sorry. Okay, copy, and I'll paste it here. So negative sequence, I have told you what has to be done. Only voltage source we have to, negative sequence network. We have to draw the negative sequence network. So this is a negative sequence network. This is a positive sequence network. Positive sequence network is this one. Okay, in the negative, what we have to do? We have to change only the voltage sources we have to remove. So we remove the voltage sources. This we are going to remove, this we are going to remove, this we are going to remove. Rest of all will be the same. There will be no problem in rest. So we will be including this. So this is the negative sequence, and this is your what? This is xt1, this is xt2, sorry, this is transmission line for transmission line, This is XL1 and this is XT2. The same notations are there. Now, what is important for me is zero sequence. That's the most important. So next is zero sequence network. Now, before drawing the zero sequence networks, let me draw the zero power bus from where we will draw all these networks. So what we have there, we have here a switch, and then we have series switches. Okay, after that we have here shunt switches. We have here shunt switches. Okay, this is your ground, zero power bus. For a zero sequence network, we will draw like this. Okay, so this is this is the switches we will have. Sorry, this is not a switch, this is the reactance, zero sequence reactance, impedance or reactance, whatever you want to write, X naught. These are the switches. Let me draw these switches now. So one will be like this, another like this. Whatever way you are, these are switches just to close and open the switches. So these are the switches. So here we have a switch. So shunt switches, series switches are S1 and S2, as I am writing the same thing. Shunt switches will be S3, S4. Okay, this is the zero sequence reactance. Now have a look at what's going to happen individually. So in case of generators, XG not 1 will be there, and then we have to add 3XN, because why? This is reactance grounded. So that's in parallel XG2 only. Transformer on the primary side, series switch will be closed, shunt switch will be open. Secondary side, shunt switch will be closed, series switch will be open. Moving to the transmission line. Transmission line simply represented by XTL naught. There's no problem. Next, now transformer T2, series switch will be open, shunt switch will be closed on the primary side. Secondary side, series switch will be closed, shunt switch will be opened, and then again we have this is generator 3. Only we have zero sequence reactance. There will be, because that's solidly grounded, fine. It's not a problem. So we don't have any 3x and it's not a reactance ground. It is solidly grounded only. So let us draw it for your understanding. Let me draw it on the another page. So now, one by one, I will be drawing. First will be, what will be generator number 1? Generator number 1, what we have? Generator number 1, we have a reactance. So I'll be drawing that. Zero sequence reactance, that is XGO1. Then since it is reactance grounded, you can see it's reactance grounded here. So 3xn will be added to zero sequence. So we will add here. Three xn will be added. Generator number 2, we don't have any problem. So this is generator number 2 is solidly grounded. Solidly grounded. So no reactance will be there. That will be, value of that reactance will be 0. So we'll so that will be xg2 of 0. Next is the transformer. Have a look at the transformer in the switch diagram. Now transformer primary side is series switch, that is star connected, neutral grounded. Series switch will be closed. So this switch will be closed. So it will be connected with this X, whatever you could TL1 not 0, whatever you call. So series switch, shunt switch will be opened. So now what I will be doing, so I'll be closing the series switch. I'll not drawing that here. Sorry. I'll be closing the series switch. Okay. Here, and on the primary side of the transformer, series switches are closed. So this is like, we will represent it by like this. X transformer T1 0. Okay, now moving on this side, have a look here. So on the secondary side, what's going to happen? The series switch will be opened and shunt switch will be closed. So this switch here will be opened here. That this switch is going to be closed. This switch is going to be closed. Why? Because series switches will close only when the winding is star connected, neutral grounded. Shunt switches will close when it is delta connected. Yeah, secondary is delta connected. So we are going to close it here up to ground. Then I will be drawing the ground later on. Now this will be opened here. Why? Because on the secondary side of the transformer, the winding is key. Because why we have done this? Because on the secondary side of the transformer, series switch is open, shunt switch will be closed. That shunt switch we have closed. So here you can see this shunt switch we have closed. Now the series switch we are going to keep open. Okay, now series switch we have kept open. Now next is transformer T2. So in transformer T2, what's going to happen? Let us see the type of winding what we have. Transformer, we have delta. So series switch again will be opened and shunt switches will be closed. So series switches will be opened. That means this switch will be opened. Shunt switch we are going to close, because series switch will be open. Shunt switch we are going to close. So that's what we will be doing here. So here series switch will again keep open like this. Okay, sorry. Okay, this is fine for us. Okay, series switch on this, on the, we are talking about the transformer T2. Okay, now transformer T2, this is the winding. Sorry. Okay, XTL0. Oh, sorry, this is a transmission line. First we have to connect the transmission line. Fine, transmission line is there. Have a look here. Sorry, my mistake. Transmission line I have not included. This transmission line simply represented by the reactance. Now coming to the transformer. Transformer T2, series switch will be opened, shunt switch will be closed. So this will be opened, this switch will be closed. Fine. Okay. So series switch will be open now. Here. Now I'm going to close the shunt switch. Shunt switch I am going to close. Okay. Shunt switch I am going to close. Then what we have a 0 sequence winding of the transformer. Okay, so we will include that winding. So that is XT20. Fine. Now coming to the secondary side of this. Secondary side of this winding is what? Winding is star connected neutral ground. That means series switch will be closed, shunt switch will be open. So we'll close the series switch. This switch we will close. Shunt switch will not be drawing. Then that's all the transformer we have finished. Now last is the generator again. In case of generator, what we are going to do? In case of generator, it is simply represented by the reactance, because there is no solidly, it's solidly grounded, not reactance grounded. So this will be represented. So let me draw the ground now. This is the ground, and this is the reactance we have. Sorry. This is the reactance we have, 0. So one by one part we'll be considering now. Let's consider one by one part now. So this was for the generator number 1 with red, with this side. This we have drawn zero sequence network for. So this was for generate, sorry, I will write later on. This was for generator number 1. This was for generator number 2. Okay. Up to here is for transformer number 1. Okay. Then this is for the transmission line. Okay. Now up to here where the series switch will be closed. I am not drawing that series switch. You have to understand that yourself now. So it will be transformer number 2. And finally, we will have generator 3. So let me write all these things. So this is the representation for the this is the representation for the generator 1. This is the representation for the generator 2. This is for your understanding, I'm showing it. This is for the transformer number 1. This is for the transmission line. This is for the transformer 2. And this is for the generator 3. So it is very important how to draw the zero sequence network. I think it's clear for everyone. Moomin, it's clear or not?
Yes, sir, I am.
Okay, this is very important. So you have to draw it like this. You have to practice it. Okay, then we have a very important question. Sometimes the question may be given like this. So we'll be moving fast. ठीक है, calculations आपको करूंगा मैं zero sequence खाली मैं बनाऊंगा, positive sequence I will not draw. Okay. Now in this case, you can see, have a look at this question. It's a very important question. Just a second. Have a look at this question now. See, let me elaborate this question. Okay. See, draw the sequence network for the power system shown in figure. So I'm interested only in, although we have to draw all this, but zero sequence networks are very important for us in the examinations, gate examinations, competitive examinations. Sometimes the connections are given, you have to draw, or sometimes it is drawn, you have to tell what type of connections we are. So both ways it can be asked in the examinations. Okay. Now, here, draw the sequence networks for the power system shown in figure. Now, each and every has got some specifications are given. So, in this case, before drawing the sequence diagram, you have to bring it on the common platform in the sense that you have to choose the base values. You have to choose the base values for what? For the complex power and for the voltages. And after choosing the base values, once you have done that, then you have to draw what? You have to draw the sequence networks. So in order to start this solution, so let the base MVA, we can see 50-50 is everywhere, almost everywhere. So let the base MVA for complete system be 50 MVA, okay, and base kV for generator side is 11 kV. Can choose any value, but I have chosen generator side this 11, and transmission line side, obviously that will be 220. You can use base value multiplied by secondary by primary, and then you can get 220. So I'm writing it, just all these things, per unit values, how to do it. Transmission line side 220 kV. So number one, what we will be getting, we will bring them on the common for platform. So per unit reactance of generator G1. So G1 and G2 it is same. So X1 I will be writing X2. It will be J point 2. Why? Because the base values are same, and X naught in this case is, it will be same. Why? Because multiplied by SB new divided by SB old, that is 50 by 50, multiplied by sorry, VB old by VB new. So we are not whole square. So that we don't need to write. So I have told you, when you have the same ratings on the rated values, then we can write simply the same values. Okay. Number second, let us move further. Per unit reactance of generator 2. Per unit reactance of generator G2. So G2, it is different now. See, per unit is zero point 0.5 and 30 MVA we have. So X1 will be equal to X2 will be equal to J.15 multiplied by SB new, that is 50, divided by SB old, that is 30. So that value is coming out to be J.25 per unit. Similarly, for zero sequence in the generator, zero sequence will be J.03 multiplied by 50 divided by 30. 11 kV bases are same, so we are not writing that. So that value is coming out to be J.05 per unit. So generator also we have finished. Now let's move to the transformer. Third is per unit reactance of transformer T1. Per unit reactance of transformer T1. So you can see here all are same. X1, X2, X2, everything is same. So he has not given. That means everything is same. So that is J.1. And we have base values also 50. So that will be same. So X1 will be equal to X2 will be equal to X0 will be equal to J.10 per unit. Okay. Now next is per unit reactance of transformer T2. Let's see what is that T2 transformer. Can he? It is same J.05, but it is on the 50 MVA. Now we have it's on the 30 MVA. Old MVA basis 30 MVA. So X1 will be equal to X2 will be equal to X0 will be equal to J.075 SB new divided by SB old, but voltage is same, so we are not mentioning it. 0.125 per unit. Okay, we have got for transformer T2 also. Per unit reactance of transmission line, it is J.1. Okay, J.1 for line 1 and J.12 for line 2. So, okay, next is per unit reactance of transmission line 1, and that is X1 will be equal to X2 will be equal to zero point 0.1 per unit. Okay, it is given 0.1 per unit. And now here one thing we have to assume, if it is not given for the zero sequence, suppose it's not given for the zero sequence, we can't take directly this as the zero sequence. So there is one assumption we have to make. That's a very important point here. For transmission line, whatever the reactances value are given, those are for the positive and negative sequence reactances. But for the zero sequence, what we have to do we have to assuming zero sequence reactance of transmission line 3.5 times of its positive sequence reactance. So you have to assume this. Somebody may ask, sir, why we are doing it. So this will be 0.35 per unit. Okay. Now basically, what happens? There is a difference in magnetic fields in zero sequence inductive reactance. When we are talking about the overhead transmission line, then there is definitely a difference in the magnetic fields in zero sequence inductive reactance of the overhead transmission lines. That is being considered 2 to 3.5 times as large as the positive sequence reactance. This ratio, which what that is being considered 2 to 3.5 times as large or as greater than as we have positive sequence reactance. This ratio is considered toward the higher side. That means value is higher in terms of higher proportion, whatever the specified ranges are there for the double circuit lines. For double circuit lines and grid lines, there are some grid wires, there are some specifications. So this wire is considered, this value is considered a bit higher. But main reason for taking it so much times 3.5, we are taking on the higher side 3.5 times.
Hi sir, how are you, sir?
Who is this? Okay, so what is being considered here? This is 3.5 times greater. So then zero sequence is considered as 0.3 times as compared to that of the positive and particularly positive sequence networks. Okay, so similarly on the similar ground, so reason is mainly difference in the magnetic fields. Now next is per unit reactance of transmission line. Per unit reactance of transmission line 2. Okay, so in this case,
सर आपने दिमाग खाया, मुझे सिर में दर्द किया, कितना पढ़ाते हो?
who's she? कौन है ये? Woman?
Yes, sir.
Who is she?
सर पता नहीं कौन है.
Who is calling this one? कहाँ से आ रही है आवाज?
सर पता नहीं, हमारी क्लास को तो नहीं लग रहा है कोई.
But she is not in the class.
सर ये क्लास का स्टूडेंट नहीं है, शायद कोई
तो ये
बाहर से
इन
है।
कैसे है ये?
सर पता नहीं, हमारी क्लास का तो नहीं लग रहा है कोई.
सर इकलाक सर की क्लास में भी ऐसा हुआ.
नहीं, who is she? ये क्लास में कौन से है? मतलब why she is coming? Who is this? Zubair 18?
यस सर, रोल नंबर 18 मैं हूँ।
Why she is disturbing? है कौन ये? Who is this idiot?
सर ये किसी का नाम 35 फैजान था, उसने लीव किया।
35 फैजान?
यस सर, वो हमारी क्लास का
क्लास
नहीं
में
है
तो
कोई,
किसी को
सर
नहीं
उसने
है.
लीव।
But how he has joined? उसने ज्वाइन कैसे किया है?
सर 35 स्टूडेंट ही नहीं है कोई हमारे क्लास में, शायद उसने पहले ही फर्स्ट सेम में ही लीव किया था।
ओके, आप ऐसा करो, यू स्विच ऑन योर वीडियोस, ठीक है? स्विच ऑन योर वीडियोस, ठीक है सारे? 35 है ये, so I can take it out him from the log list. ये प्रॉब्लम है ना, इसमें दोबारा ज्वाइन कर सकते हैं खुद ही, है ना?
यस सर, इसमें खुद ही अगर लीव करेंगे तो फिर थोड़े टाइम बाद खुद ही ज्वाइन कर सकते हैं.
But I will make him permanently disabled. रुक जाओ, just a second. He's just disturbing the class. Okay, Moomin.
यस सर.
Just a second, I will control it now. मैं यहाँ से इसको control करूँगा.
ओके सर.
Hello, Professor. What's up?
Just a second, I will. Okay, what we'll do, we'll stop this presentation here only, okay?